Okay, so far we learned a new function called exponential function. We learned a way of creating new functions called composing functions. From there, we found a special class of function called inverse functions. So now we combine them and we look at what would the inverse of an exponential function be. Now remember the setup for inverse for exponential function. Let's say the input is 0, the output was 1. The input was 1, the output is 2, the input is 2, the output is 4. Now for f inverse x, we would expect the input output to switch. So when input is 1, the output should be 0. When input is 2, the output is 1. When input is 4, the output is 2. Notationally, what's happening here? 2 to the 0 is 1. 2 to the 1 is 2. 2 to the 2 is 4. What we want here is something is happening to 1 and it gives me 2. So something happens to 1 and gives me 2. Something happens to 2. Something happens to 2 and it gives me 1. And then something happens to 4 and it gives me 2. This should be a 0. Sorry. And the graph of the potential function can also be drawn because we know that this is y equals 2 to the x. And then this is y equals x. And if I take the reflection, then the graph of the potential function, this is the potential inverse function. And that's what the graph looks like. So we give this a name. The inverse function of exponential function are called logarithmic functions. Notationally, that something which we said before is log, which stands for logarithm. Now let's see. In the exponential notation, this was called the base and this was called the exponent. We've retained the idea of the base and we still call this base. So we don't call x exponent anymore. And then the input and the outputs have swapped. So you should know how to change from exponential to logarithmic notation. Now this is exponential, right? Now identify that this is the input, this is the output, and this is the base. So if I have to rewrite, I switch input and output. So 2 is now the output. I use the word log. The base remains the same. And this is now my input, whereas this is my output. So same here, I would say log, the base is still b. That's the output becomes the input, and the input becomes the output. Similarly, log, base e, output and input switched. Changing from log to exponent, that's the base. So 5 becomes x, right? The input and the output switch. B cubed becomes 64. 3 to the y becomes 7, and so on. Some basic properties. So we can derive these properties from the exponential function. A to the power 1 is a. If I rewrite this in log form, this is log base a, switch the input output. So basically says if these numbers are the same, the base and the logarithm, then it's always 1. This says log base a of 1 is 0. So log of 1 is always 0. Now there are some inverse properties, right? Remember, if f and g are inverse function, then f of g of x equals g of f of x equals x, which means log base a of a to the power f of x equals f of x, and a to the power log base a of f of x equals f of x. So they kind of cancel each other out, which is the idea behind inverse function. So for example, log base 4 of 4 to the 5 just becomes 5. 6 to the log base 6 of 9 becomes 9. 3 to the log base 3 of 17 becomes 17. This is a more If I change f of x to x, then that's the property. There are some additional properties that logarithm has. For example, log base a x times y becomes log base a of x plus log base a of y. Multiplication becomes an addition. Log base ax over y becomes log base ax minus log base a y. Division becomes a subtraction. The final idea or the final topic here is going to be domain and range. Let's look at exponential function. Let's say I look at e to the x. Now x can be anything. So the domain is negative infinity to infinity. The range is always positive. Because if you take any number and you raise it to any power, you can never make it negative. You cannot even make it zero. So the range is 0 to infinity. And this is also clear from the context of the graph, right? That's the domain. It's everything. But that's the range, and it's only the positive numbers. Now logarithmic functions, it should be switched from y equals e to the x, say. This means that the domain has to be positive and the range is everything. Again, this is clear from the graph because if you look at the graph of the logarithmic function, that's the domain and it's only the positive numbers not including 0, and the y values are the range, which is everything. Now just like you have the natural exponential function, there's something called the natural logarithmic function. This is, if I have log base ex, then this is written as, pronounced as ln of x. It's just a notation thing. If you see ln x, it just means that the base is e. So nothing changes, it's still a logarithmic function, which means that its domain is still 0 to infinity, and its range is still negative infinity to infinity. Okay, so that's the end of this particular topic, which is exponential function.